uns für euch und wir hoffen, ihr kommt auch nächsten Monat und übernächsten Monat. Wir sind bei Event Nummer 7 und stolz drauf, macht uns Spaß und euch hoffentlich auch.
Genau. So, Sandra, what's happening today?
Cookies?
Nein. No, later.
Okay.
Yes. Same as always, Sandra.
Zuerst ein Vortrag,
Ja.
dann ein Quiz und dann ein Vortrag.
Genau. So today we will have, as always, the talk, first in English, then a little break, some music, the quiz with a great game, and now we have Angus here who was late for his congratulations and goodbye. Hi, Angus.
Angus, this is your slide.
This is your slide. Come here.
Come here, you get your present now. He was late. Zu spät.
Angus. Yes, we will miss you.
It's a box. Eine Box.
That's awesome.
Please show it to the public. It's an astronomy on top. Yes. Okay. Thank you. So, as we were saying, for the interruption, we will have English talk, music, quiz, German, and some great prizes to give today.
Ja, es gibt Preise für euch, also ab und zu mal zuhören. Und wenn ihr irgendwelche Fragen habt, dann müsst ihr nicht mit uns reden. Für die Introvertierten hier eher, ihr könnt auch einfach eine E-Mail schreiben oder per Twitter oder auf einen YouTube-Channel. Und wir sind uns nicht so schade, das für euch vorzulesen. Und dann müsst ihr gar nicht richtig mit uns sprechen. Ist dann aber auch schwer, Preise zu gewinnen.
Genau. So, if you have questions, you want to sponsor us, you want to be part of the event, you want to give a talk, you have new ideas, we're always welcome to hear about you. And you can contact us in social media, because, you know, new generations. And you can also email us. Anyone with a name tag is part of the organizing committee. If you have astronomy questions, you can always ask the astronomers on the audience. They're very happy to answer them. And if not, just, you know, catch them with a beer and then they'll be happy. So my insights tell me that also whatever you see on the tables is free. It's thanks to our sponsors, so yeah. Please, you know, take it.
Ja, wenn ihr uns in irgendeiner Form sponsern wollt, dann kommt natürlich auf jeden Fall zu uns. Und ansonsten das Programm für heute im Detail. Anna, what's on the menu today?
On the menu today, it's a very interesting thing, but before you jump to the menu, I'm going to tell you this. We actually do live stream, so people in their homes can actually see us as well, you know, in the comfort of their beds, which means that we go live, and anyone who doesn't want to be a stream on this, please don't come to the stage. That includes the breaks.
Das stimmt. Wie wir dank der DSGVO wissen, dürft ihr nicht mehr irgendwo abgebildet werden, und deswegen müssen und möchten wir euch erzählen, dass wenn ihr hier vorne auf die Bühne kommt, dann seid ihr Teil des Livestreams, also auf eigene Gefahr hier vorne auf der Bühne.
Now, finally, for what we came for. So, the first talk is in English, and we will have Adrianos Golemis, and the second talk is Martin Quast, and it will be in German. So, let me tell you a bit about the first talk. This is a medical doctor, Adrianos Golemis. He works at the European Astronaut Centre in Cologne. Very interesting. He actually works on taking care of the health and the well-being of the astronauts. Shh. Danke. Yes. So, this is when I learned the silent fox from the Germans.
Schweigefuchs.
Yeah. As I was saying, Adrianos works on taking care of the well-being of the astronauts before, during, and after the space-time flight. And he worked before in Antarctica, I believe that, also doing some research. And also with ESA, the European Space Agency, for a year. Yeah, with them. And today he will tell us about humans in space.
Ja, heute auf Englisch können wir Adrianos Golemis willkommen heißen. Er ist Arzt am Europäischen Astronautenzentrum in Köln und überwacht dort die Gesundheit von europäischen Astronauten vor, während und nach Raumfahrten. Also mal abgesehen von selber hochfliegen, ist das so das Nächste, wie man dran sein kann. Und wir werden heute was darüber erfahren und auch was isolierte Antarktis-Stationen damit zu tun haben. Und ja.
Yeah, so what time is it, Sandra?
Cookies?
9.
Ah, Applaus.
Clap time.
Applaus.
Thank you. Hi, everyone. I'm the English talk. I'm kidding. I'm Adrianos. Thanks a lot for having me. Good to be here. I'm an amateur astronomer, but when I don't have my amateur astronomer superhero costume, I'm a medical doctor. So, yeah, it's a nice atmosphere. I'm here to share with you some of the things that we do. As you heard, I work in the European Astronaut Centre. Actually, that's a place that is very close to you. It's like 35 minutes to the north, between Cologne and Bonn. And yes, a bit about Antarctica and space analogues. So, without further ado, why do I start this talk? This is the plan. I don't know if you see it. It's a picture of Mars and a picture of the Moon. I guess the goal for exploration, human exploration with human spaceflight, is in the far future or in the near future to settle other worlds. And here you see an artist's depiction of Mars, you know, terraformed in little bubbles and colonized by humans. And here something more realistic, lunar base. And I think currently there is an international shift towards going to the back to the moon first, and then in the years to come, move onwards. This is maybe, most of you are familiar with it, but I always like to mention it. This is a slide about the European Space Agency. This is Europe's gateway to space. And actually, ESA is comprised of several member states. It's not related to the European Union. It's an independent institution. And it covers almost the entire spectrum when it comes to space. So you see that there are missions of satellites, there are robotic missions, there are telecommunications, but our part here in the European Astronaut Centre has to do with humans, so with astronauts. And I'd like to highlight that actually astronauts, they go into space, they go into this place that you see here, the International Space Station. Europe has contributed a part to the ISS, as we call it, the Columbus Laboratory and some other parts. And why do astronauts actually go to space? They go because of research. So they do a lot of research in different aspects, and one of it is research on themselves or on their colleagues that has to do with medical and psychological aspects. So this research is not only done in space, but also in space analogues. So places on the Earth that simulate some of the conditions of spaceflight. And we'll talk a little bit about that. So just a few photos of this little place 35 minutes to the north from here, the European Astronaut Centre. This is one of ESA's centers. And as you can tell, it's related to astronauts. So there are 3 floors. The ground floor is where I work. That's the Space Medicine team and some of the some other divisions. Then on the first floor, you have astronaut training. So all the trainers that take care of preparing the crew, the astronauts, for their mission. And on the third floor, you have the astronauts themselves and the people that do the support, so the planning, the logistics, and all that. As I mentioned, it's not so far away, so if you want to visit, you just go on the website and you contact the reception and you'll find a way through. There are tours and all. And on the way I look at it, the way you look at it, on the bottom right side, you see a photo of the training hall. That's a place where you have a lot of mock-ups where astronauts actually go to, and they train on what will they use once they go into space, the International Space Station. So on the top right, you see a pool that is part of the European Astronaut Centre. And in this pool, does anyone know why we have pools, actually? Why we have a big pool in a training center? Any ideas? Come on, feel free. Yeah? Sorry, to simulate? Exactly, yeah, because when you're immersed in this pool, you kind of simulate the lack of gravity. It's not exactly the same, but you move in a way that is similar to it. So astronauts actually, they put on a specific spacesuit and they go in here to train on how to conduct EVAs. We love acronyms as much as astronomers do. So maybe even more. So EVA is extravehicular activity, meaning a spacewalk, when the astronauts put on the spacesuit in space and go out to create some maintenance. And of course, here is a younger version of me in the middle. That's when I was an intern at the European Astronaut Centre 6 years ago, and that helped me come back here and work permanently. So, a brief history of time, no, a brief summary of what happens to humans when we go to space. Obviously, we are all evolved and adapted to 1G, to life on this planet where gravity is present. What takes place? What changes do we see in the body once we leave this beautiful planet? A major one that is connected to astronomy is radiation. You know that here on the Earth, we are protected by the Earth's atmosphere and also the magnetosphere, the magnetic field of our planet. Once you leave that, you're actually receiving higher doses of radiation. And this can come from solar flares, coronal mass ejections, or cosmic radiation. So actually, the more you're exposed to it and unprotected from the Earth's environment, the higher the risk is to develop cancer, and you can even have acute radiation syndrome if you're really unlucky. Of course, astronauts are protected as much as they can be by shielding and so on. Now, what else can happen to you? Actually, when you're living in zero gravity, you see me here, right? I'm standing. I'm moving my hand. I'm doing this actively, but passively, some muscles of my body are working just to keep me standing. If I was doing the same thing, this talk from space, I would be standing or floating, and I would do no effort at all. So actually the muscles that, I don't even think of it, I just stand. All these muscles would not work. So all these muscles would lose mass and density, and gradually they would degrade. And something similar happens to bones. All of this just because we lack gravity to which we are all adapted to. And of course you have some more specific risks. So you can have small troubles with eyesight, your cardiovascular immune system, everything is affected when you leave this planet and you go into zero gravity. So, I mentioned the European Astronaut Centre. Right next to it, in this DLR campus, you have some other places, the Flight Clinic. This is a place that you see on your top right. I have to inverse always, I'm looking to you, you're looking at me. But this is a place where actually astronauts go to have their medical tests. So we, as the flight surgeons, this is the term of the medical doctor that follows the astronaut, we have to check that the astronaut passes a lot of medical tests before they go to space. So part of the role is make sure that they are fit for flight and that they are in optimum condition. So once they do expose themselves into space flight and all the side effects, they will not suffer too much and they will be able to come back and with the rehabilitation process be healthy again, completely healthy. And of course the most interesting part is when they are actually in flight, in space, and this is where you obviously have to follow your astronauts' health, and you have regular calls with them to see if everything's okay. If there is a problem, you try to mitigate it, either by giving recommendations or closer monitoring. So I'm a medical doctor and I'm happy to be part of this team. It's not only doctors, luckily. It's a very diverse team. You have exercise specialists, you have people that do the planning of the tests and the gathering of the data. You have people that take a look into countermeasures. By the way, do we all know what is countermeasures? It's actually something that you use to mitigate the effect of spaceflight on the body. And on the bottom, you see a photo of the ENVI Hub. That's another facility very close to the European Astronaut Centre, where the European astronauts go for the rehabilitation phase once they come back. Who was the last European to fly? Came back in December. Most of you in this room should know it. German? Yeah, Alex Gerst. I should say European astronaut on a German passport, of course, because we are European and I think there's great value in collaboration. So when Alex came back in December, he came to this building in the ENVI Hub, and that's where he did most of his rehabilitation process. And I should mention that also the medical team, no worries, takes also part in astronaut selection. So if in the future there's another astronaut selection and you apply, we might be checking some of your tests. Yeah. Think about this if you want to buy us beers and so on tonight. So here I included just a few photos because we as flight surgeons, and again that's a term for medical doctor that looks into astronauts' health, we do some training, and sometimes we follow the astronauts around as they do their training. Here are a few photos from Russian Star City. In the middle you see a Soyuz capsule simulator where they train on how to fly. So here you see a huge centrifuge, again in Moscow, in Star City, and the astronaut goes on the edge, and this spins them around to adapt them to high G loads. Now on the other side of the globe, in Houston, that's also where some of the training takes place. And here you see a pool like the one we have in Cologne, only bigger. And I don't know if you've watched Armageddon. Maybe you've seen this pool appearing in that movie. Again, here this is EVA training. This is a building that I don't like so much on the exterior, but in the interior you have this wonderful setup. This is the Mission Control Center in Houston, and the flight surgeon also sits somewhere here and tries to follow up the mission. Just for comparison, this is the Mission Control Center of the Apollo era, of Neil Armstrong's time. Smaller and, of course, more archaic. But anyway, I'd like also to talk a bit about space analogues. Like I said, analog is a place that simulates some of the conditions of spaceflight. And you have plenty of analogues and types of analogues. No analog is perfect. What do I mean by that? That no analog can fully simulate the conditions of being in space, what happens to your body and psychology. I'm lucky enough to have been involved in a few analogues. So I'll start with this. This is a bedrest study. A bedrest study. Does anyone want to take a guess? It's actually a study where you stay in bed. We see a person here lying down. And actually, while you lie down, you do this for 2 months in a row. You do not get up even to read or to go to the bathroom. Of course, you can turn, so you cannot have any effects on yourself. But you do not lift your head. And this is really tough. But notice also that the head is lower than the feet. And actually, in this configuration, you simulate on a cardiovascular level and on many other systems what happens to the body while in 0G. So a lot of experiments can take place on such studies. There is another model called the dry immersion. And all of this because we cannot run all the tests that we want in space. There are only very few astronauts, and it costs a lot actually to run all the tests in space. So luckily you have these analogues that help with carrying out experiments and extrapolating with a larger N number. And in the previous one, I was working as a doctor actually, so I was not taking part, but I'll talk a little bit about Antarctica. This is a place where you have several stations. One of these is called Concordia. It's a French-Italian station. Concordia means harmony, so it's very fitting. And I was working for the European Space Agency there for a year in 2014. So why do we go there to simulate space flight? Actually, it's isolated. This means that for 9 months out of 12, you cannot leave. It's so cold that planes do not fly in or out of this place. So you're on your own, basically. A little bit like astronauts in space. Here I just listed a few parameters. Why does this actually simulate space? Very briefly, it's on high altitude, so you have difficulty. You need an extra effort even to go up the stairs. It's very monotonous, so your psychology is affected. There is nothing to see, no birds, no weather changes, no mountains, nothing. A little bit like being in a tin can in space, and so on and so forth. Of course, you're in real danger. So if this catches fire, you really have to save your station. There is no other place to go, and there is no plane coming to take you out. So what is the research being conducted in such a place? There are 3 main categories. One is physiology, and we in medicine like to use this term to describe the body. Whatever happens to the body is physiology. How does our body change in these extreme conditions? Then, of course, you have psychology, and like I mentioned, this is something very important and sometimes overlooked, but we can split this in personal psychology, like my mood, how does it change within a year in isolation, and also team psychology. Do we get closer, work better together, or do we go further apart if we stay in the same place and we see each other every day, every single hour maybe, for a year? And of course, we also test countermeasures, so ideas to mitigate the effects of isolation and the other parameters. We can check if the ideas we have, the countermeasures, work or not, and apply them to space. Here I listed a few results, but very briefly, some of them are anecdotal because actually the N number is small, so very few of us go there or to space to conduct them. But it seems that your metabolism may speed up, your sleep suffers a lot when you're in these extreme conditions, and these are also things that have been observed for astronauts. And I'll take you on a quick trip through the experience of going there. So me, I'm Greek, so I had to leave Greece. I think I did like 6 or 7 stops on plane hopping to New Zealand. Then I took a big plane, Italian plane, that lands on the sea. Here in the photo, you can actually see the frozen sea. This is not really Antarctica, this is the frozen sea, which is really puzzling when you land with your plane on the frozen sea. But it's safe enough. And then you take these smaller planes to go to the station in the middle of nowhere. On the way back, we took a boat. By the way, the map is inversed here. Don't get confused. That is an icebreaker, but we get a little bit stuck in the ice nonetheless. But the most important part is the time that you have there. So actually, in the photo that I included here, you see the room, and that's the only private space you will have in the winter. It's very small, and it's the only private part you have. And in the summer, you have to share that. So that's like, I don't know, 5 square meters, and you have to share that in the summer. Really packed. The temperature can go as high as -14. That's high enough, right? But in the winter, it can drop down to -80. So you really have to cover yourself up. It takes some time to dress up to go out. And it's a very, very, very light version of a spacewalk because you really have to think before going out. You cannot just open the door. I already talked about psychology. What's interesting here to mention is that if you have a bad day, you can spread this around and everyone has a bad day. You know, I misbehave. But actually, and more importantly, if you make a constant effort to be positive, you help yourself and others. And actually, it's a chain reaction, and everyone gets feeling better. I mentioned that it's monotonous, but this doesn't mean that it's not beautiful. So here I have a photo. This is the first sunrise after after 3 months of polar night. So 3 months that you don't see the sun, and then you see a photo like that, scenery like that. And this is the Astronomy Centre. I did not make it on purpose, but it is. So here it's not Concordia, it's on my way back because we didn't see any animals or birds. But on the way back, while we were stuck on the ship, at least we saw seals and penguins, so you really feel, it was worth the trip after a year. And obviously I should not leave without mentioning the sky, which for me it was a huge motivation. So even if I had a bad day in the polar night and I hadn't seen the sun, I was sleeping very badly. It's so dry, all these effects, but you could just go out, of course, dressed in your little spacesuit, and you would look at the sky, and it's the clearest sky in the world. So that's really something to behold, and I wish you all had the chance to experience something like that. Here you should, in principle, see the aurora, the southern lights, but I think the contrast of the picture is not so good. But okay, you can go to Antarctica and see it for real, right? So. Oh, right, okay. So, and my last part of the presentation is actually the Analemma. That's a strange word that I came across once. Imagine yourselves on this window, one window of this wonderful pub. You just place a camera, you never move it, not even an inch, right? Looking at the sky, and you just take a photo at precisely the same time, once a week. So, during daytime, right? Precisely the same time. So you'll see the sun moving, even if you have exactly the same frame. And here in the photo, you can see the path of the sun of the sky during a year. This is related to why we have seasons, why summer is warmer and winter is not. So actually, if you make this photo during a year, you see the sun moving around the sky. This is a very good depiction. And I tried to do the same in Antarctica. That's my result. Not so impressive, but I have to say in my defense that I tried with 3 cameras, only one worked, and it was the worst camera, so, But I was happy enough to be able to do it nonetheless. It's a bit fuzzy, and, the wind makes it a bit shaky. But it was the first time that someone took a picture of the Analemma from the south, from the Antarctic Circle. And that's why it became the NASA APOD, so Astronomy Picture of the Day, in 2015. If anyone wants to take a photo, I mentioned a few documents and books regarding human spaceflight and what happens to the body. If you're interested in further reading, after the beers of tonight. And with that, I'd like to thank you very much. And, sorry, I got one plus. Thank you very much, and if you have any questions, I'll be happy to be around. Thanks a lot.
Thank you very much for the talk. So we're going to go to a question session, but first I want to remind everyone who's watching this on YouTube that they can write questions on the chat, and we will try to answer them as well. So,
und ihr könnt auf Deutsch fragen. Ich übersetze dann.
Genau. And yes, if you ask a question, you get a ticket for the raffle, which you can win great things, Astro Swag. Yes. So questions.
What's the date where it's maybe possible to travel to Mars? Is it in 2048? So they say you can travel every 2 years, but it's better after 15 years.
Unfortunately, I'm a medical doctor. I should ask someone from the strategy department. But actually, what you mentioned is a valid point. Of course, we have no date set, and like I mentioned, the current mindset is first to go back to the moon, which will take some time, in years, and then use the knowledge from going back to the moon and establishing a base for the first time, a permanent base, to go further on. What you mentioned actually is a good point, because it depends, if I understand correctly, on the orbital mechanics. So the relative positions of the Earth and Mars favor the trip on certain years. So I think the planning, when it comes to be, will take that in mind. Hopefully not, hopefully soon enough.
Other questions from YouTube? No? Over here?
Sure.
Do you want to come here, try to speak louder?
Do you want me to try this one?
Sure, we can try that one.
As you mentioned, being in space, the muscles lost quite fast on mass. The question is, what is the longest time for a human or for an astronaut being in space? This is the first question. And the second question, what was actually or who was the astronaut who have been the longest time in space?
Thanks. I hope I'm going to respond correctly to your question. So no, it's a good point, and as you mentioned, all of these effects, we have studied them up to a point. So you mentioned the longest stay. We can talk about cumulative stay, or in one flight. The person that has the longest record of cumulative stay in space is the cosmonaut Polyakov, Dr. Polyakov. If I'm not mistaken, he has more than a year, significantly more than a year in total time in space. Of course, if you come back and go in a next mission, you readapt to Earth's gravity, and then you go back to the effects of space flight. I don't remember what the record is for a single flight, but recently we had the 1-year flight of a NASA astronaut and a Russian cosmonaut, and this was kind of a change. Usually when astronauts go to the ISS, the International Space Station, they stay more or less 6 months. Some of them go for shorter missions, some of them slightly longer, but this transition to 1 year, to year-long mission was done a couple of years ago, and it was exactly to be able to measure what you mentioned. So the effects, that's the sustained effect of being in 0G. Thank you.
So, from your tests and also, let's say, in the rehabilitation period, so after the astronaut came back, did you find any differences between women and men? Any big difference?
First of all, I should I should say that they are not exactly our tests. We usually, so how does this work? You have scientific teams that propose experiments, and ESA or the international partners, the other space agencies, they pick some of them and they are implemented in space. And usually our role is to help facilitate the experiments, but not necessarily to look in the results. However, yes, from bibliography and literature, we know that there are some changes. I had a slide from NASA actually that you could see the effects on male and female. For the better part, they are common, but of course, given the body's physiology, you can see differences. I think some agencies even have different radiation limits. I mean, they propose or they allow you to go to space for this amount of time, depending on the maximum radiation that you can receive, and this can change between men and women as well. Yeah, we can go in length if you want later. Yeah.
Great. One last question here.
So my question is, what are the main risks? Like, what are the main diseases that you expect to have when you are going for the long trips? Like, we do not think about this because we always have access to medical doctors on Earth.
Yeah.
So, for example, I heard or what are the main risks and what kind of things people should think in advance before? For example, like teeth disease. So it's hard to get a. And I have also another. Like, can I have to? The other, I heard that nails and hair is growing faster when people are in space. Is it connected with this faster metabolism that you have mentioned?
Thanks for both questions. Starting from the latter, I'm not sure. And also what I mentioned for higher metabolism, first of all, just to be careful, this was observed in some people, but this came from Antarctica actually, and the N, so the number of subjects, is not big enough yet to be 100% sure that it's for real. But it's a good probability. I'm not sure if there is a direct connection to the rate of nail and hair growth. However, yeah, I should look into it in more detail if you want me to be able to guess why exactly does this happen in space. You have a lot of effects. For example, yeah?
This is true, like this is happening.
I have also heard about this, but as it's not something of a very big medical risk, yeah, I have not really dug into a lot of details. But it's a good point, and let's have a look afterwards. So this is a good bridge to your first question. First of all, I'd like to say that astronauts have a very thorough and deep training. So I'm sure they can do hairdressing. But more importantly, on top of everything else that they learn, how to pilot the capsules, how to perform all the experiments in space, they also have emergency medicine training. And this is important because, like you said, we cannot predict everything. Right now, after some years of human spaceflight, we have a good understanding of what can take place. There is, for example, a syndrome called space motion sickness. Once you go into space in the beginning, you have a lot of effects. One of them is that you can be sick and nauseous because of the conflict of what your eyes see, that I do not move, and what your inner ear feels. You do not have gravity, so you feel unbalanced. All of this we know, and we have medication and strategies against them. But yes, there are things that we do not know, and we only now begin to understand. And that's why, if it's something grave, the astronauts have good training and material on board to handle it. And worst case, for now, around the Earth, they also have the possibility of evacuation, which will not be the case as easily when we go to the moon or further on.
Great. Thank you very much. So let's clap one more time.
Oh. Thanks a lot.
So, a couple of announcements before we go to break, and digest all that we hear right now. First of all, as I say, if you participate in any of the questions or in any of the games, you have a chance to win prizes, which means that we have to get a sponsor. So if you ever want to sponsor us, we're happy that you sponsor us. But that also means that we get sponsored from the European Southern Observatory. And I'm glad to say this time this in English and not in German, because that's very difficult. And we also get sponsored by the Euclid Space Probe. Yep, and all the presents today will come from them, basically.
Ja, wir möchten uns an dieser Stelle bei den Sponsoren bedanken, die wir schon haben. Ihr könntet natürlich die nächsten sein. Und im Moment sind es ganz große Organisationen, die auch eigentlich jeder kennt. nämlich die ESA und die ESO und die von ESA die Euclid Mission. Und von denen kriegen wir immer kleine, süße, nette Geschenke, die wir dann an euch weitergeben können, was uns sehr freut und wir gerne weitermachen möchten. Und das bringt uns dann zu dem ganz kleinen Beitrag heute, den ihr leisten könnt. Und das ist tatsächlich zur Abwechslung mal was Politisches, ganz heißes Thema.
Genau. So, as usual, we ask you for your kleine Spenden, your donations. And the way we ask this is by asking you a question, you can vote the answer to the question, and that is, what do you think is going to happen? Brexit or return. I knew I had a weird term. Return it is. And although this seems political instead of scientific question, actually does affect everyone and does affect the way they will sponsor research, future jobs for researchers in all different fields. So we also felt appropriate for this time the question. Our colleagues, I believe Arti, who's somewhere there, will go around with the pint glasses, and as I say, just any donations will help, and then you can get cooler things later.
Ja, wir würden euch gerne heute fragen, einfach nur so als Motivation, eine kleine Spende für uns zu geben, die wir wirklich ausschließlich benötigen, dass wir ein paar Flyer drucken können, damit mehr Leute von uns erfahren, damit mehr Leute so was Cooles hören können, wie den Vortrag, den wir gerade gehört haben, und dass wir einfach kleine Sachen kaufen können, wie zum Beispiel diese Wasserflaschen. Wir haben auch Tassen diesmal und wir packen da unser Logo drauf, das heißt, Schleichwerbung ist direkt mit dabei. Ja. Und wenn ihr einfach eine ganz kleine Spende habt und die in das Glas tun könnt, dann wären wir froh, und damit ihr motiviert seid, dürft ihr euch heute entscheiden, was glaubt ihr, wie wird es enden? Gibt es den Brexit? Möchten die Briten einfach da stehen und sagen, wir haben das entschieden, wir machen das jetzt? Oder machen sie einen Rückzieher, was einfach mal cleverer sein sollte, und machen den Return, wie wir es jetzt genannt haben? Und das wäre natürlich auch für uns Wissenschaftler ganz nett, wenn wir in einer Union bleiben könnten.
Sandra, how many presents do we have?
1, 2, 3, 4, 5.
5.
5.
So 5, yes. But if you don't have, money, no kleine Spenden, no worries. You can also win prizes by participating on the Instagram frame. So normally our dear friend Eleni goes around with the Insta frame that we have here, or you can come to the stage, take pictures, post them online, and we select the winners very objectively, obviously. And you won again. You always win. You're the queen. And this time, these are the winners. So come on the break and collect your prizes. Very cool things. Posters, mugs, different things. Yes.
Ja. Wenn ihr ganz, ganz arme Studenten oder PhD-Studenten seid und wirklich gar nichts für uns übrig habt, dann könnt ihr immer noch ein Foto machen und mit diesem Instagram-Frame, der hier rumsteht, ganz leicht. Eleni geht immer gerne rum und fotografiert sich hier mit jedem. Und dann ganz objektiv entscheiden wir dann oder wählen zufällig aus. Und wenn ihr euch gerade wiedererkennt auf dem Bild, dann kommt in der Pause, die sofort anfängt, mal nach vorne, und ihr kriegt einen von diesen tollen Preisen, die wir mit euren kleinen Spenden gekauft haben.
Yep. And we always announce the winner a week before. We try to, so follow us on social media. Favorite thing to say here. Twitter, Instagram, Facebook, just follow us. Okay, we are almost at the break. One quick thing, so as Eleni said, today she will sing for us with Rocco. I don't know what they're singing, but we will discover that. We'll have a kleine Pause, we'll have a song, and then we have a quiz game.
Und das Ganze nochmal auf Deutsch, bevor ihr endlich mal 5 Minuten eure Ruhe habt. Es folgt jetzt eine kleine Pause, in der könnt ihr gerne auf eure beliebten sozialen Medien gehen und uns folgen, damit ihr kein Event mehr verpasst. Das würde uns jedenfalls freuen. Und dann, ganz, ganz heiße Sache, direkt nach der Pause kommt dann der Song von Eleni und Rocco, gefolgt vom interaktiven Quiz. Heute mal mit einem anderen Quizmaster.
Guest Quizmaster.
Ja, aber ich mache das Deutsche.
So,
ja.
Break time.
Break time.
but here we have a doctor, so we said we took some pills to absorb that.
One, two, yeah, it's on now. Yeah, but check the sensitivity level though, yeah? I think it's distorted. Put it down. Check, 1, 2. The sensitivity. Check, 1, 2. Yeah, okay, yeah. Yeah, okay.